All right. Have you ever looked at the Pokemon Go Combat Power Multiplier table, which I'm showing here on GamePress, and wondered where the hell did all of these numbers come from? Like, why 0.094? Why 0.4225? Well, I've done some examination of the table, and I've done some reverse engineering, and I think that I understand how Niantic came up with it. So what I want to show, and here it is in the Game Master file. What I want to show is the process that I think that Niantic went through back in 2016 to come up with this table. And so you can see some interesting aspects to this table. So level 1, level 10, level 20, level 30, and so on are short numbers, and then all the rest are longer numbers. And so what I've done is I've pulled the table into a spreadsheet over here. Make this bigger. Okay, that should be big enough, I think. So you can see the shorter numbers. I believe that these numbers were typed manually. So I think that they found numbers that worked, and then they simply typed them into their table manually, and then all the rest of these numbers were filled in by, it's actually an interpolation between these two numbers. It's not a linear interpolation, but it's actually, if you square these numbers, it's the linear interpolation of the square of the numbers. And so what I want to show is how I think Niantic came up with this in the first place. And to do that, we need to look back at the statistics that Pokemon had back in 2016. They've changed. I think they changed sometime in 2017. But these are the original stats that all of the Pokemon shipped with when the game was first released. And so this is only Generation 1 because the game only shipped with Generation 1. And so there was some formula that they used to come up with these numbers based on the stats of the main series game. That's not important. I'm not going to go over that. But what I think Niantic did was they wanted the average Pokemon, and we'll figure out what average means in a moment. They wanted the average Pokemon to have somewhat nice combat power numbers. So I think what they probably did was they went, to this table and they went, well, what is the average Pokemon? So we can ask for the mean of, or I guess, it's the mean of, and then it would be B2 through B152. No, it's not mean. What is it? Average? Yeah. Okay, and then we can extend it over this way. Okay, so the average attack value of all the Pokemon is 151. The average, I think this is defense, right? Yeah. I'm so zoomed in here. Give me a moment. Okay. The average defense is 146, and the average HP is 128. So we don't have to just look at the average. We can look at the median. And then the median of, yep, that'll work. Okay, so the median is 150 for attack. The median is 150 for defense. And the median is 120 for HP. Now, I think that they said, well, this 150, that's pretty nice. Let's just call the average Pokemon. We'll just say the average Pokemon has 150 attack, 150 defense, 150 HP. And so that's what we're going to start with. And I think they had already decided on a combat power formula. And I think, so the combat power formula is, if you want to measure sort of how strong a Pokemon is, you can take a product of its stats. People call this the stats product when looking at PvP Pokemon. The combat power formula is kind of like a stats product. But what it is I can show it over in this column for each Pokemon. So the combat power formula is the attack times some combat power multiplier. We don't know what that is. So the attack is B2 times, and then they did the square root of C2 and D2. That's the HP and the defense. And then they did all of that divided by 10. And so there's some combat power. So let's just look at a combat power of 0.5 for all of these stats. Okay. So that, and we can autofill. So at a combat power multiplier of 0.5, Bulbasaur would have 335 CP, Ivysaur 537, and so on and so forth. And you'll notice that they weigh the attack in the formula much higher than they weigh the defense and the HP, because they take the square root of the product of the defense and the HP, whereas they take the attack directly. So we can rework this formula slightly. Because we have a square root, and then we have the combat power multiplier in here twice, we actually have the combat power multiplier squared inside of a square root. So we can actually just take the combat power multiplier out of the square root and put it squared here instead. And that comes out with the same value, 335. So if we have all the same three stats, if we have 150, 150, and 150, we have 150 squared, so we can actually take 150 out of the square root, the 150 squared out of the square root here as well, and we can just look at, well, here we can do what is it, 150 squared times 0.5 squared, and and then we have to divide by 10. Okay, and so the average Pokemon would have, at a combat power multiplier of 0.5, it would have 562.5 CP, which seems like a relatively reasonable CP for the average Pokemon at whatever this combat power multiplier is. But Niantic hasn't yet figured out what the combat power multipliers are going to be. And so let me walk you through how I think that they came up with this table. Okay, so the first thing we're going to do is we're going to decide on some nice CPs. And we're going to do it for levels 1, levels 10, 20, 30, and 40. Okay, now we want, I think this is what Niantic said, they want the average Pokemon at level 1 to have a CP of 20. The weakest ones will have a CP of 10, the strongest ones will have a CP more like 30, but the average, or actually not in 30, but like 40 or 50 for the strongest ones. But the average will be about 20. And then at level 10, they want the average to be 400 CP, and then 600 CP at level 20, and then 800 CP, excuse me, I think they went 800 CP, and then they went 1200 CP, and then they went 1400 CP. So that's what they want the average Pokemon's CP to be. Now, we can start plugging in numbers and trying to figure out how what works here. And so let's add a row above. This is the level. This is the goal CP. This is the CPM. And then this is the calculated CP, which is going to be based on the CPM. So we'll just put 0.5 in here for now. And then let's calculate for our average Pokemon. Oh, sorry, my cat is meowing. So our average Pokemon, the CP formula is going to be 150 squared times this number C2 squared. And we already worked out that that's C2 squared. We already worked out that, oh, and then divided by 10. I always forget that divided by 10 thing. Okay, so at a CPM of 0.5, a level 1 Pokemon would have 562.5 CP, or 562 CP. That's obviously way too much. So we can go to like 0.1, 0.1, and we're getting a lot closer. Okay, so we need a number somewhere around 0.1. Now, I don't think that they did this manually for each of these 10 levels. I think that they simply went, okay, well, look, this this increases by a factor of 20, and then increases by a factor of 2, and then increases by a factor of 1.5, and then it increases by a factor of 14/12. So we can just calculate, if we get it right for the level 1 CPM, we can just calculate what the level 10, 20, and 30 should be. And that is, so we take the C2 CPM, we square it, then we multiply that by the ratio of 400/20, which is 20, and then we take the square root. And that's because the CPM in the formula, the CP formula is linear when squared, and so we need to square it, do a linear factor, and then square root it. Okay, and then we can do, so we can take that formula and we can do the exact same thing here, but instead of it being the C2 CPM, it will be the C3 CPM, and then it's the ratio of 800/400. Okay. And then again, but now it's the C4 CPM, and that's a ratio of 1200/800. Okay, and then we'll do it one more time. And this is the C5 CPM, which is CPM directly above us. And then it's 1400/1200. Okay. So, and then we can extend the calculated CP as well. Okay, so we have here, we're above our goal in all of these values. So I think that Niantic just played around with these numbers. Let's check 0.9. Okay, that's too low. And then let's check like 0.95. And that's kind of getting high. So let's go 0.94. Okay, that's a little bit too low still. And so I've worked this out. If they used 4464, if they used that number, then CPs come out pretty nice. Now, here's an interesting thing. So this CP is very, very close to 20, and if we go much smaller than this, we drop into the 19 range. These numbers are above 1400. Like this is 1405, this is 1204, this is 803. Now, I suspect that the original CP formula was not divided by 10, it was divided by 100. And I think that the original goal CPMs were not 20, 400, 800, 1200, and 1400. I think the original goal CPMs, when they were first making the table, were 2, 4, 8, 12, excuse me, 2, 4, okay, why can't I do this? 2, 40, 80, 120, and 140. And it would make more sense that the minimum CP would just be 1, and that, you know, a Pokemon around, let's say, 80 combat power is a relatively strong Pokemon. And I think that's why these numbers are off slightly from what the goals were. Like, I don't think the goal was, you know, 1400. I think the goal was 140, and who cares if it's 140 and a half? And at some point later, they went, you know, these numbers are kind of small. That's kind of pathetic. Let's just divide the formula by 10 instead, and we'll just make all of our numbers 10 times bigger. So that's why the minimum CP went from 1 to 10. Okay, so we have, I think we have our 5 level 1, level 10, level 20, level 30, level 40 CPM values. So what we're going to do is we're going to go over here, and we're going to say level CPM, and then we're going to need 1, 2, and we're going to go to 40 here. Okay, let's keep going. Okay, we don't need that. And then we'll do, okay. And then we're going to just manually copy these over. So 0.94, 0.094. And then for 10, let's go 0.44245. So we'll round that up, 0.4225. And then at level 20, we'll go 0.59744. So we can round that down to 5974. 0.5974. Okay, and then 0.73171. So we can round that down to 0.7317. 7317. 0.73117. And then 0.79034, so we can run that down to 0.7903. 0.7903. Okay, so we now have our CP numbers for levels 1, 10, 20, 30, and 40. And all we need to do now is we just need to fill in all the values in between. Now, as I said before, because the CP formula uses the CP squared, these numbers are linear when squared. They're not linear by themselves. So we're going to take the CP squared, CPM raised to the 2, which is G2 raised to the 2, and we're going to fill that whole table. Okay, and these values are going to be linear when we interpolate between these. Okay, and so how do we do that? There are 9 steps between level 1 and level 10, right? So that's step 1, 2, 3, 4, 5, 6, 7, 8, 9 steps to get from level 1 to level 10. So we can take, so this will be the square root of, and then we need the ratio, or actually, well, we need it's linear. It's linear in the square. So we need to take H11 minus H2, and then we multiply that by 1 over 9, and then we finish the square root. Okay, there was a problem. I missed parentheses. What did I do wrong? Oh, that's what I did wrong. Okay. And let's go make sure that I actually have that right by looking and cheating at the true CP table. No, I don't have that right. Oh, we also need to add. Okay, so we need to add back on the G2 value. That's what, 0.3359. Oh, no. Do I do it inside of? No, I don't do it inside of the square root. How do I do it? G 231. Oh, why can't I do this? It is linear. H linear in the square times the 9th. Now I square root. Oh, do I add? I don't do G2, do I? I actually do it here, and I use H2. Yeah, 16639. So that's correct. Sorry for bearing with me. That's what happens when I try to do algebra in my head. Okay, and now we want to extend this all the way down, but if we try to do that, we need to anchor these values, which we can use $signs for. Okay, and then if I try to extend it here, what happens? Okay, so now I need 2/9. And then if I select these two and I extend, I think. Oh no, it didn't. Okay, and then we go 3/9, and then 4/9, and then 5/9, and then 6/9, and we should have done a formula for this. And then 7/9, and then 8/9. And so we should be getting close at like 3 point. Yeah, okay, we're getting close. Okay. We'll use a formula for that for the next one. Alrighty, so we need to do the same extent. So we've got the interpolation going here, and we need to do the same interpolation for the other further down in the table. Okay, so what is the formula here? the formula to do the interpolation. Now we need to change around. So now we're interpolating between row 11 and row 21. And so we go from 21 to 11 and 11, except that there's now 10 steps between row 10 and row 20, not 9. So we do 10 steps here, and we want there to be a formula for this. So we need 1/10, and we're on level 11, so we need F12 minus 10. 10. Okay, and let's extend that. So we should be looking at, for 19, we should be looking at 0.5822. Check. Level 19, 0.58. Okay, we're doing good so far. All right. And then let's do the same interpolation again for levels 20 through 30. Now we're going to 31. So 31 to 21. And then now it's F21 minus 20. And then 21, right? Oh, F22. Okay. Then we can extend that. We should be at 0.7193 at level 29. Yes. Okay, and then we got one more reconstruction to do. And this is going from 41, or it's going from 31 to 41. So it's 31, 31, and then we have F32 minus 30, and we can extend that. Okay, so we now have what I think is and we can hide this column because it's only used in the math. I think we have what is essentially the combat power multiplier table. Now, I am using a spreadsheet, and a spreadsheet does all the calculations with double precision floating point numbers. However, the CPM table is actually single precision floating point numbers. Single precision floating point numbers only have about 7 decimal digits of precision. And so we need to round these numbers to around 7 digits. Now, this is not exact. This is not precise because, again, there's no way to make double precision math exactly match single precision math. CPM has float prox, single precision approximate, and this is equal to round UND of G2, and then we want to round to 7 digits, and then we can fill in the whole rest of the thing. Formula has been, yes. Okay, so here we have the CPM table using the procedure that I explained. So let me go over how that procedure went in the first place. Look at the statistics for all of the Pokemon when released at level in 2016. The mean and median number for their stats, the attack, defense, and HP, are around 150. Now, HP is a little bit lower. So we'll just say that the average Pokemon has 150, 150, 150 for the 3 stats. And then we decided that we wanted the average Pokemon, this one with 150 across all its stats, to have a CP of about 20 at level 1, about 400 at level 10, about 800 at level 20, about 1200 at level 30, about 1400 at level 40, We then worked out what CP would make that work at levels 1, 10, 20, 30, and 40. We found this number, and we just applied math to that number to get the remaining ones. And that came close enough to our goals. And again, there is no actual Pokemon that has 150, 150, 150 stats. We're just talking about the average. So it doesn't really matter that we missed our target by a slight amount. And then we manually copied over the values that we found, and we just used a handful of digits for each at levels 1, 10, 20, 30, and 40. And then we found the numbers in between that make the CP increase the same at each level. So the CP increase from 1 to 2 is the same as the increase from 2 to 3 all the way up to level 10. Yeah, so, and then we did some rounding. We rounded to 7 digits to make it match approximately the original CPM table. Now, let's actually take a look at how close we got. So let's copy the original CPM table. And it obviously levels 41 and on were not in the release, so we're going to ignore those. We go true CPM, and now let's do some math to see how close we got. Delta. Okay, and then delta is, it's I2 minus J2. We can fill the rest in. Okay. And, well, that's too many. So format, number, and, you know what, let's truncate. Let's truncate to 7 digits. Okay, truncate 7, I think. No, it's trunk. Okay. And then these. Okay, actually we're truncating too much. We need to truncate to 8 digits. Okay. So you can see we were off. We were not off in the 7th digit on any of these numbers. Because when we truncated to 7 digits, they were all the same. But in the 8th digit, we are off on some of the numbers. And that, unfortunately, is just a necessity because there is only 7 digits precision for floating point numbers, but this spreadsheet calculates much higher precision. So we actually got every single digit correct up to the 7th digit. But on the 8th digit, we were slightly wrong, and that's just a limitation of the spreadsheet. So that is, I believe, how Niantic came up with the CP table when they were originally designing the game back in 2016.